So what is a system of equations? So the case we'll be discussing today is just going to be a system of two linear equations. So in this case, I'm showing here, it's just two equations in perfect slope-intercept form. So we have, our y-intercept and our slope that are very obvious here in these two equations. So in a system of equations, what we're trying to solve for is we're trying to solve for the ordered pair where both lines have a point. So this is the intersection between the two lines. So how do we solve a system of equations? How do we solve for this point? So there are two main methods, and these are elimination and substitution. So we'll start with elimination here. What is elimination? So in elimination, we are eliminating a variable to solve for the other variable. We can either add or subtract to do this, and once we have solved for one variable, we can solve for the other. Now, we can also use elimination twice to solve for both variables, and I'll show an example of that later on in this video. So let's solve this problem with elimination. Let's solve for this point here. So our first equation here, we have y is equal to x plus 4. And then we have y is equal to 2x plus 2. And right now, I can just see that if I subtract this first equation, or the second equation from the first equation, I see I have a y minus y. Now this is just the same number minus the same number, so that it's just going to be equal to 0. And then we got to move our equal sign down. And it's really, really important that we make sure that our variables and our numbers are all on the same side. So, right, so we have this x above this other x, we have this 4 above the two constants above each other, and then we have the y above the y. And they're all on their own respective terms of sides of the equal sign. So now we do x minus 2x, and we're going to get negative x, and then we get 4 minus 2, so we're going to get plus 2. And now we'll just add x to both sides, and we'll get x equals 2. And then from this, there's two different ways we can now do this. The first way to solve for y here is I can just plug in this 2 for either x for both of these equations. And a good way to check your work here to make sure you've done it right is to plug this in for both of the equations, and then you should be getting the same y. And if you're not, maybe something went wrong. So let's plug them into this y is equal to x plus 4, this y is equal to x plus 4 equation just first. So y is equal, now we're plugging in 2 plus 4. So we're getting y is equal to 6. Now let's make sure, just by plugging it into that second equation, the y is equal to 2x plus 2. So y is equal to 2 times 2 plus 2. That's y is equal to 4 plus 2. So y is equal to 6. So I've just confirmed there. I'm pretty certain the answer is 2 and 6. Now we can also solve for y without finding x as well. So to do this, I'll just rewrite the equations up here. Y is equal to x plus 4, and y is equal to 2x plus 2. So right now the equations are set up in a way where the y's are going to cancel out. But if I want the x's to cancel out to solve for y, I'm going to need to manipulate these equations and then make the x's basically the same. You'll see what I mean after I do this. So what I can do is I can multiply this entire equation by 2, right? And as long as I multiply both sides of this equation by 2, then it still remains the same equation. So then what I end up with is 2y is equal, and then it's really important we distribute this 2, right? This is 2 times x plus 4. So that's equal, actually I'll just draw an arrow here. 2y is equal to 2x plus 8. And now what I'll do is I'll move this equation just below it. So y is equal to 2x plus 2. And now you can see if we subtract this equation here, 2y minus y, well that's just equal to 1y, right, which is just equal to y. And then 2x minus 2x, that's just going to be 0. And then 8 minus 2, so plus 6. So y is equal to 6. So you can see we can solve for both variables using elimination here. So let's move on and talk a little bit about substitution now. So what is substitution? So in substitution, we are solving one equation for one variable and then substituting that new equation into the second equation. And then same as with elimination, once we've solved for one variable, we can solve for the other, same as with elimination. So this can be kind of scary when you first try it, but trust me, it is not too bad once you just practice a little bit. And hopefully, as you see me do it, it'll become a little easier for you all. So let's solve a substitution. So this is going to be a very, very basic form of substitution. So we can see here we have, and I'll write here, I'll write the equations like I did with the elimination demonstration. So we have y is equal to x plus 4, and then we have y is equal to 2x plus 2. Now what I'll do here, since I know that the y's, the point I'm looking for, the y's are the same and the x's are the same. So what I can do is I can substitute in this x minus 4 for this y here, because I know it's equivalent. So what I'll get is x plus 4, I'm sorry, if I said x minus 4, I meant x plus 4. X plus 4 is equal to 2x plus 2. Let's subtract x from both sides here. So 4 is equal to x plus 2. And then subtract 2 from both sides here. And I'll get 2 is equal to x, or x is equal to 2. And now I can just solve for y, just like I did with the elimination demonstration. So, and I'll show you how to solve for y this way too, if we wanted. So if I want to solve for y, when I have these two equations, so I have y is equal to x plus 4, and y is equal to 2x plus 2, I'm going to need to isolate x. And this is a good skill that we're going to really need later. So the first step here, I'll choose this first equation here just because x isn't being multiplied by a constant or anything. I'll subtract 4 from both sides. So I'll get y minus 4 is equal to x. And now what I'll do is I'll substitute in this y minus 4 for this x right here. So I'll get y is equal to 2 times y minus 4 plus 2. So y is equal to 2y minus 8 plus 2. Let's subtract 2y from both sides. And then let's combine this negative 8 and plus 2, that'll be negative 6. So we'll get negative y here is equal to negative 6. And I'll divide both sides by negative 1. And I will get y is equal to 6. So as you can see, we can use either elimination or substitution, and both methods work fine in this case, but as we'll see in the future, sometimes substitution will work better, sometimes elimination will work better. It just all depends on the problem, and a really large skill of systems of equations, or of solving these, is just knowing when to use which method. And that will only come with practice. So let's do some practice problems. So these problems here, they can seem kind of scary, but all they are kind of jumbled up slope-intercept form, right? So I can solve this for y, right? I'll just subtract 3x from both sides. That's really y is equal to negative 3x plus 10. And this equation here, I can subtract x from both sides. And then I can divide both sides by 2. I get y is equal to negative 1/2 x plus 5. Now, I'll show you though, you don't need to do that to solve these problems. So let's solve with elimination. And remember, solving elimination, we can manipulate the equations so that a variable cancels out. So let's do that. So looking at this equation right now, I'm seeing that, we don't have any of these equal to each other. So right now, I need to manipulate the equations in a certain way so that a variable cancels out here. And what I think I'm going to do here is I'm going to multiply this first equation by 2. Okay, so I'll multiply this. You can't see that very well, but you'll see here. So I'll multiply 2 times 3x plus y is equal to 10. And I'll get 6x plus 2y is equal to 20. And then I can write the second equation underneath it, and I'll get x plus 2y is equal to 10. I'll subtract the second equation from that first equation. 6x minus x is 5x. 2y minus 2y, well, that just cancels out to 0. 20 minus 10 is equal to 10. And then I can just divide both sides by 5 here, and I get x equals 2. And then let's do it for y. Now we can either plug in x here to solve for y, but I'll just solve y with elimination. And the way I'll do that is I'll multiply that second equation by 3. Okay, so I'm going to do 3 times x plus 2y is equal to 10. And remember, I'm multiplying it by 3, so I have a second 3x. Because I have a 3x in that first equation, I want a 3x in that second equation now. And I'll get 3x plus 6y is equal to 30. And then I'll write that second equation, that first equation underneath it. This 3x plus y is equal to 10, and then we'll do some subtraction. So 3x minus 3x is just going to be 0. 6y minus y, that's just going to be plus 5y. 30 minus 10, that's just going to be equal to 20. Divide both sides by 5 here, I get y is equal to 4. So I get 2 and 4. And if we wanted to, we can just substitute in either of these numbers just to make sure we're right. So I'm getting 2 and 4 here, so let's try this. I have 2 and 4. Let's do it in that first equation. 3 times 2 plus 4 is equal to 10. 6 plus 4 is equal to 10. And then perfect, 10 is equal to 10. So it works for that first equation, so that works. Let's do it for the second one now. So 2 plus 2 times 4 is equal to 10. 2 plus 8 is equal to 10. 10 is equal to 10. Perfect. All right. Now let's solve this with substitution. So the first thing I need to isolate a variable, right? That's our first step here always, is we have to isolate a variable. So let's isolate the x here by subtracting 2y from both sides. So x is equal to negative 2y plus 10. Now let's substitute in this negative 2y plus 10 in for the x in that first equation. Remember, it's really important that we distribute that 3 to everything in here. So 3 times negative 2y plus 10 plus y is equal to 10. So we have negative 6y plus 30 plus y is equal to 10. So I'm going to subtract 30 from both sides and then combine my like terms, combine my negative 6y plus y to negative 5y. So then what I'm going to get is I'm going to get negative, sorry, that should be a negative 5y. Sorry, let me erase that really quickly. That should be a negative 5y. Negative 5y. And then 10 minus 30 is negative 20. Divide both sides by negative 5, I get y is equal to 4. And then I'm just going to plug y into the second equation to just make sure, right? So x plus 2 times 4 is equal to 10. X plus 8 is equal to 10. Subtract 8 from both sides, and I get x is equal to 2. So perfect. All right, let's do another example here. So which method is easier to use here? Well, let's have a look at it. Substitution here, I can see that I'm not really going to be easily able to kind of isolate any of these variables here, right? I can't isolate x here in the first equation by dividing by 30 on both sides, or negative 30. It's going to end up with some nasty fractions, and same with the second equation, right? Neither variable, I'll be able to isolate them without some nasty fractions. But let's multiply the second equation by 2. Multiply this by 2. I am going to get 30x minus 24y is equal to negative 162. And then let's put this second equation, or the first equation underneath it. So negative 30x plus 4y is equal to 2. And then what I'm going to do here, instead of subtracting, I'm going to add. We can still do the same thing here. So 30x plus negative 30x is just 0. 24y plus 4y, or sorry, negative 24y plus 4y is just equal to negative 20y. And then negative 162 plus 2 is just equal to negative 160. So now I'll just divide both sides by negative 20. If I divide both sides by negative 20, so 160 divided by 20 is just going to be equal to 8. So y is equal to 8. And then I can just substitute in that y is equal to 8 for either equation here. Or I could also just solve using elimination. I might do that as well for x. I think it might be easier than plugging the 8 back in. So I'm going to multiply the first equation by 3 now. Okay, so negative 30x plus 4y is equal to 2. And let me just multiply this by 3. I'm going to get negative 90x plus 12y is equal to 6. And then let's put that second equation underneath. So 15x minus 12y is equal to negative 81. And you see I've done this so we have the two 12y's there. And then I'm just going to add. So negative 90 plus 15x, or negative 90x plus 15x is going to be equal to negative 75x. And then 12y plus negative 12y is just going to be equal to 0. And then 6 plus negative 81, well, that's just 6 minus 81, which is equal to negative 75. I'm going to divide both sides by negative 75, and I'm going to get x is equal to 1. So I'm getting 1 and 8 for my solution here. And then again, I could just check these. So by plugging them into either equation. So let's plug in 1 and 8. So my solution here I found was 1 and 8. Let's plug it into that first equation. Negative 30 times 1 plus 4 times 8 is equal to 2. Well, that's going to be negative 30, and then 4 times 8 is 32, so negative 30 plus 32 is equal to 2, and perfect, 2 is equal to 2. But remember, this is not enough to say that the system of equations is true. That's just saying the point is true for this first equation. So we need to try it for both equations before we can for sure say that 1 and 8 is a solution. So 15 times 1 minus 12 times 8 should be equal to negative 81. So that's 15. And then 12 times 8 is going to be equal to 96. So 15 minus 96 is equal to negative 81. And then 15 minus 96 is equal to negative 81. So negative 81 is equal to negative 81. Perfect. We've just proved the system of equations. And again, this is a case where elimination is going to be far easier than substitution. You could use substitution to solve this problem, but it would be very messy. It would take a long time, and there's a really good chance you'd make a mistake just because you're going to end up with a lot of fractions, and that's going to make it much, much tougher. Okay, everyone, so let's do this next practice problem now. So we have negative 5x plus 5y is equal to negative 25, and 3x plus 2y is equal to 10. So the first thing for this first equation, what I'm going to do is I am going to divide both sides by 5. Okay, and that's also known as just multiplying it by 1/5, same thing. So I will get negative x plus y is equal to negative 5. And then I'm going to just add x to both sides here, and I'm going to get y is equal to x minus 5. So you can see in this method I'm doing substitution, right? Because I'm isolating one variable in one equation. Now doing that, I can now substitute in this x minus 5 for this y in that second equation. So we'll get 3x plus 2 times x minus 5 is equal to 10. So we need to make sure to distribute this 2 here, right? It's not just 2 times x is equal to 2x minus 5. We need to distribute that 2 to that x and that negative 5. So it's going to be 3x plus 2x, and then 2 times negative 5 is minus 10. And that's all equal to 10. So let's combine our like terms here. So 3x plus 2x is going to be equal to 5x. And then we'll add 10 to both sides, and we'll get equals 20. We'll divide both sides by 5 now, and we'll get x equals 4. All right, so let's, actually, you know what I'll do is, yeah, I'll just substitute in that 4 for both of these equations here, and let's make sure I get the same y. So for the first equation, if we substitute in that 4, negative 5 times 4 plus 5y is equal to negative 25. That's negative 20 plus 5y is equal to negative 25. We'll add 20 to both sides. We'll get 5y is equal to negative 5. And we'll divide both sides by 5, and we get y is equal to negative 1. So my solution kind of got here so far is 4 and negative 1. Now let's plug in 4, negative 1 into that second equation, this one right here. And let's make sure that it works in that equation too, so then we can be sure that we got this right. So 3 times 4 plus 2 times negative 1 should be equal to 10 if I did this right. So 12, 3 times 4 is 12, and then 2 times negative 1 is minus 2. And then 12 minus 2, is that equal to 10? Yes, that is equal to 10, so we can say that we've proved that 4 and negative 1 is a solution to the system of equations. So let's move on just to one more example here. So we have 8y minus 9x is equal to negative 3, and 5y minus 8x is equal to 10. So this one I'm seeing right now is going to be by far the toughest, right? Because I can't really isolate either variable, either y or x, in either of these equations very well. So substitution's not really going to work well without some nasty fractions. And then elimination, I'm going to need to multiply by some pretty big numbers here. Now the numbers I'm going to choose here, I'm going to choose to multiply this first equation by 5. So this first equation I'm going to multiply by 5. And the second equation I'm going to multiply by 8. And you see that's to make these y's equal to each other. I'm going to make the constants in front of the y's equal to each other. So 8y times 5 is going to be 40y. And then negative 9x times 5 is going to be minus 45x. and then, I'm sorry, 40y minus 45x, and then negative 3 times 5 is going to be equal to negative 15. So then from this, I'll just do the second equation here. So 5y times 8 is 40y, and then negative 8x times 8 is minus 64, and then 10 times 8, that's going to be equal to 80. So then what I'm going to do now is I'm going to subtract the second equation from the first one. So the 40y minus 40y is just going to be 0, and then negative 45x minus negative 64, I forgot an x there, and then so it's going to be negative 45 plus 64. Also you can think about it as 64 minus 45, so that's equal to 19. So 0 plus 19x, and then negative 15 minus 80, that's just going to be equal to negative 95. So then I'll divide both sides by 19 here, and I will get x is equal to negative 5. So then now we can either solve for y by making those x's equal to each other, or I can just try plugging it in. And I like plugging this number in here. I like plugging, but I find when I like plugging that into both of these equations, because it's a way of solving for the other variable and also proving it right. Just because if I do it for both and I get the same number, I can be pretty certain that I got it right. So I'm going to plug that in for that first equation there, that x in front of the negative 9, and I'm going to get 8y minus 9 times negative 5 is equal to negative 3. So 8y, now negative 9 times negative 5 is going to be plus 45, and that's equal to negative 3. I'll subtract 45 from both sides here, and I'll get 8y is equal to negative 48, and then I'll just divide both sides by 8 here, and I'll get y is equal to negative 6. So now my solution I have is negative 5 and negative 6, and now I'll just make sure that's right by plugging both those numbers into that second equation. So 5 times negative 6 minus 8 times negative 5 is equal to 10. So I'm going to get negative 30 plus 40 is equal to 10, and then perfect, yep, 10 is equal to 10. I've proved that system of equations as true. So negative 5 and negative 6 is my answer. Okay, so if you have any questions, feel free to email me, or you can always leave your question in the comment as well, and I'll try my best to answer that as quickly as possible. You can also email me if you want any one-on-one tutoring, and I'll also leave some links for that in the description too. Thanks, everyone.